Hello friends. So our today's question is to sum. Okay. So given an array of integer nums and an integer target. Okay. So we are given an array of integer nums and an integer target. So what we have to do, we have to return indices of the two numbers such that they add up to targets. Okay. So we have to return indices of two number from this nums array such that they add up to make a sum of sum equals to target. Okay. So you may assume that each input would have exactly one solution. Okay, so like how many number of inputs we have, we will have only one solution, and we don't have to use the same element twice. Okay, you can return answer in any order. Okay, so basically this is our example. So what they are asking from us, we are given a nums array and we are given a target. Okay, so we have to find indices like two elements from this nums array, two indices from this nums array whose elements will sum up to give sum equals to target. Okay, so like in this case, if we are having the target of 9, so if we see 2 plus 7 give us 9. Okay, and if we see the next example 3 to 4, the target is 6, so we can see that 2 plus 4 give us the target of 6. So what are their indices is 1 and 2. Okay, in this example what are the indices of these 2 plus 7 is 0 comma 1. So this is our result, so this we have to return, we have 0 comma 1, so this is our output. So we have to return the indices of the element which will add up to give us the sum equals to target. Okay, so basically this is a problem statement. Okay, so what is the solution approach that we can use here is, first of all, brute force approach. Okay, so in brute force approach what you can do, you can fix one element. Okay, and then you can iterate for the rest of the element and add their sum, and check their sum is equals to target or not. If we find any pair whose sum is equals to target, then we can return that. Okay, so we will be using two loops. First for loop to iterate to make one element as fixed. So in the first iteration we will make 2 as fixed, and in the inner loop we will iterate from 7 to 15. Okay, in the second iteration we will make 7 as fixed and we will iterate from 11 to 15. Okay, 11 15. So in this brute force approach, what we are using, we are using two loops. Okay, two loops. So basically we are finding all the combinations of the nums which can ultimately lead us to a solution. Okay, so we will be using two loops. Okay, so it will take capital O of n square time complexity. Okay, now but we have to go for the optimization one. So like let's see second approach. So what second approach we can use here is like, okay, first of all what we can do is, okay, okay, so like this nums is given, this is not sorted. Okay, as you can see in second example it is 3 to 4, so this nums is not already sorted. So what we can do, first of all we can sort this nums array, so it becomes 2 7 11 and 15. This nums is already sorted. So once we will sort this nums array, then what we can do is, like for we will take a particular element. Okay, particular element, we will take this particular element, and what now if we look for this, not that 2 is 2 already we have got. Now what remaining we have to get the target which is equals to 9. So x is equals to 7, so like 7 we need to search in the remaining array, that whether 7 we are having in this remaining array or not. Okay, so what we can use here, because array is already sorted, what we can use, we can use binary search. Okay, so it will return whether the element is present at the, and it will return the element of the element which is present. In the same way, in this example it is 3 to 4. Okay, 3 to 4 and our target is 6. So first we can sort this. Okay, so when we will sort it, it become 2 3 4. Okay, now what we have, now we will take particular, okay, we will iterate from here. Okay, so we have taken, first we have taken 2. Now what remaining we want, from this, so we want 4 more. Okay, so we have to find for the element 4. Okay, so then we will apply binary search in this remaining, so we will get the fourth element. Okay, so what here we will do, time complexity, we calculate time complexity is n log n. Okay, for sorting we will take n log n. Okay, and then for each element we will iterate. For each element we will apply binary search. So for n element, binary search is log n. Okay, so again n log n time complexity will be there. So second approach, by applying by sorting, we will take n log n. Okay, capital O of n log n. Okay, so this is the time procedure that we will take. But let's see third approach, where we can perform some more optimization by using extra space. Like can we use extra space, okay, to get our solution in more optimized way. Okay, so let's see the third, which where we can use. Okay, so what we can use here is third approach, like map. Okay, map, we can use map. Okay, so in map, what we will do, first of all, we can take a map. Okay, and we can store the elements against its index value. Okay, so let's say we are having this map. So we have let's say we are giving them indexes 0, 1, 2 and 3. So we have 2 at 0th index, okay, 7 at 1 index, 11 at 2 index and 15 at third index. Okay, so we have stored all the elements of the nums against their index. Okay, so what we can do is, again, like we know the target, we know the current element. Okay, we know current element which we are currently pointing to. We want to find x such that the value become equals to target. So x is always target minus current value. So when we are at 2 and we know that target is 9, what we require is 7. Okay, we require 7, so will check whether 7 is present in this map. If it is, okay, then what is the index? So we will get the index from here. So what will take, we will iterate these element one time. So it will take capital O of n time velocity, and finding element in map is constant. Okay, so this solution will be the time complexity for this solution will be capital O of n, and its space complexity in these two approaches, our space complexity is constant, capital O of 1. But in this map we will have time space complexity of capital O of n. Okay, we are, because we are using extra space here. Okay, so by using map, we have understood the approach. Like, okay, we will map the all the element of this nums against their indexes, and then what we will do, for we will iterate this nums array, and then we will find the x. Okay, whether x is present in this map or not. If it is present, we will return its indexes value. Okay, its value, because its value indexes. And what is x? Like, we know that current plus some value will give us target. So target will always be so this some value will always be equals to target minus current value, like whatever the target we have and what is our current value. So in this way we will have x. So now let's quickly implement this solution. So first of all, we will start by creating a map. Let's say mapping. Okay, now first of all we will create an indices. We will map the value against their indices. So in this loop we have mapped the value with their indices. Okay, now we will iterate nums again. Nums dot size I plus plus. Now first of all we will find the remaining what we want. Okay, that will be target minus current value nums of I. Okay, so we will check if its count. Okay, me.png mapping dot count, okay, of remains remins remains is greater than 0, and me.png mapping of remins remains is not equals to I, because we cannot use same element twice. Okay, so if it is there, then we will return our answer. Return I comma me.png mapping of REMAINS, because they are mapped with the indexes. Okay, if we have not found anything, we will return an empty pair. Okay, now let's run this, and yeah, it is accepted. Now let's just submit and check. Okay, so it is submitted successfully. So regarding its space and time complexity, we have space and time complexity equals to capital O of n, linear time complexity, linear space complexity. Thank you for watching.